So welcome again to our class for today. We have started working on the token, and the plan was to ensure that we have, what are they calling it? The token implementation from scratch, which we agreed to do. And that's what we have been actually doing. So we are just going to continue our implementation from where we stopped last time. And I think what I'll do is I am just going to share my screen. And when I share my screen, we just continue from where we stopped. So give me a second. Let me share my screen. Okay. So share screen. Okay, I'll just share my entire screen. Okay. So here we are. The good thing about this implementation we are doing now is if you have this particular implementation we are doing, let me try to increase this. I don't know why it's not increasing. So let me, it's too big. You can see it clearly like this now, Abby. Hello,
Yes,
can you
sir.
hear me?
Yeah, I can see it.
Okay. So the good thing about this implementation we are doing is that you can actually have this implementation yourself and use it as your official implementation that you can keep deploying every time you want to create a token, or maybe someone gives you a contract to create a token and you just tweak one or two things. That's the good thing about what we are doing right now. So for our implementation for the token, we made mention that there are certain things we would have to work on when it comes to that. The first thing is the storage types. The next thing is the admin. The next thing then is the allowance. Then the next thing after the allowance is the balances. So lastly, we have the metadata and then the contract itself. So from all of these things we have just made mention of, we've been able to implement the storage type successfully. We've been able to implement the admin successfully. And then the allowance. So we started implementing the allowance. The allowance is literally what allows someone else to basically spend out of your token. So we've been able to implement the read allowance. What the read allowance does is it shows how much a person can spend. So it just returns the value a person can spend out of your own token, literally. So what we do now is we will continue our implementation from the read allowance, and we will then implement the write allowance. The write allowance, literally, what it will be doing is it should give you the opportunity, it's the function that will be called to actually create allowance for the person. So we name it, oh, sorry, Topic rights allowance. So what are the things it's going to take? It's going to take the EMV, obviously. And yeah, EMV. Then what else will it take? It will take the from address. It will take the spender address. Then it will take the amount that wants to be spent. And in our case, we know it is I128. And the last thing it will take is the expiration ledger. So what date should this allowance expire? I know that I made mention that I don't want to include all of those in it, but let's just see how it goes. I'll just add it and we'll see how it goes. Expiration ledger. So it won't return anything, obviously. The first thing we want to do is we want to create our allowance. So let's create the allowance. what allowance are we creating? Let's go to our storage types, which is serving as our data structure. So this is what we are trying to create. We want to create an allowance value, that is how much we want to allow for the person and the expiration ledger. So we'll name that allowance. And then for the allowance value, we would have, did we import this? Okay, let's try to import it. Okay. Let me see. Allowance. Okay, we imported it already. So what are the things we are going to have there? We're going to have the amount and the expiration ledger. We all know why we are not doing it in the sense that we put column in front and write amount. We all know why. Because the field here, the struct field here is named amount, and in fact the parameter we are passing it from here is also amount. So it's just nice to just do it neat and clean. So the next thing we want to check now is, before we write anything, we want to check if the expiration ledger is less than the ledger sequence. And when I say ledger sequence, we are talking about the current block number. We could call it the current ledger number. And you know, in Solidity, they call it block number. So that's what we want to check. We want to check if the amount that this person is passing here is less than 0. Obviously, you would not want to allow someone to give an allowance of 0. So we want to check if it is less than 0, because you don't want something that is minus 0. And as we know, the int 128 literally allows from positive to negative. So just to be clear, everyone is still here with me. Oh, Mubarak is here eventually. Okay, welcome, Mubarak. So the next thing we'll do is we check if the amount is less than 0. In fact, we don't want it to be equal to 0. So let's say less than or equal to 0. And also, if the expiration ledger is less than the env dot, okay, the env dot, let me off this thing. The env dot ledger dot sequence, and just like I made mention of, the sequence is just like the block dot times block dot number in Solidity. So if this is true, something should happen. It should panic. What is it panicking about? It should tell that, first of all, the amount is less than 0. Also, and, or let's just say, and the expiration is less than the sequence ledger. And expiration, oh my God, did I make that mistake? Expiration is less than sequence number. Ledger sequence, I mean. Ledger sequence. So here it is. You should panic if this is true. Then the next thing we want to do now is to create the key. If all of this is true, you should panic. But if not, what then should happen? We want to store the data, and the data key we are using is this allowance, remember? So this is the allowance data key, and I said because it is looking like a 2D mapping when it comes to Solidity. Because in Solidity, if you think of the implementation for the ERC20, the allowance is actually a 2D mapping, and that's more like tuple, the from and the person that you are spending, the spender. So this and this is mapped to this, you get. So we want to do the same thing. So we want to create our key. Our key, we start with the data key, which is this, and then the allowance. And inside of the allowance, we would now use, okay, question, I'm listening.
So one thing I know about what's it called? Is that we like it can contain a unit and a tuple, right? So for this tuple part, now we have the name and the tuple inside, which is that allowed data key, which is struct. Do you is it that when you are doing this, it's only one like one field that can be inside, not like for example have multiple tuples inside, or is it just be like one? Like for example, have allowance data key, that's a tuple inside, right? You're supposed to have multiple inside. I don't know if I'm asking the right question. Or is it just only one?
No, like this now, look at this. We can have this and have I-128.
Okay.
Where is it? I-128. There's no problem. You understand?
Mm,
It can take in anything. But because we are trying to create a kind of data key that suits what we need. You understand? And
mhm,
this is how we want to create a data key that suits what we need. Another case you could be thinking is, okay, why don't we just create a tuple of data key, like what you've just said now, whereby we say address. Okay, let me remove this one so we don't have, okay. Instead of we have allowance data key, we just say address, comma, address. This could also work. Think about it. Because this can serve as the from, and this can also serve as the spender, right? In
yeah,
that case, for every allowance data key that we are creating here, at least the spender, the from and the spender would always be passed in now, Abby.
yes.
So yes, you are correct. This can work. But the only problem we then have with this is code readability. How easy is it to read your code? So if I put address here, and you come and look at this code, what addresses would you assume are these two?
I'm confused.
You are confused.
I think I will be confused though.
Exactly. And that's exactly why it is nice to just have a struct that would define what is actually there by the field name, and you just pass it in. That's much better.
Okay.
But if you want to confuse all your enemy together, you can do the other way around. You get. Because you hear me.
Yes, I don't want to confuse my enemies.
Okay, great. So let's continue. Hope Mubarak is with us. I haven't heard his voice since. So. Mubarak, is he with us? Hello. Okay, I want to guess it's not it's with us. I want to assume it's with us. So, without wasting our time, we will continue. We would then have our allowance data key that we created here. And in it, we have two field elements, which is the from and the spender. So since it's still the same name as what we have here, we can just pass it in as from and spend, from and spender, like this. So, yep, this works. So now we have our data key. So the from and spender of everybody would always be different. So yeah. So now what is from and spender? Where are they storing it? So we say env dot storage. Oh, I guess it is this network. env dot storage dot temporary dot set. So we want to set the key. In our case, what is our key? Our key is this data key that we've just created here. And then our value is what? Allowance. This one we've created. So the amount we want to give to the person, we have added everything in this dropped. And so I'm just going to add it allowance. Allowance. Then we save that. So now we could do some certain things. Let me just do it. So we check if the amount is greater than 0. One thing we can do is we can say if for the expiration ledger dot, we can add this check sub present. All of these things I'm about to do is just to extend the life of it. But you know what? I'm going to remove it. Let's not do that. And instead of this, I'm going to change this to persistent. Now, you can make your own implementation the way you want it, and that is fine. But I'm just going to do this like this since I don't want to add too many technicalities to it. In fact, another thing I'm going to do is I'm going to remove expiration ledger from here. And just so I don't ruin things when I remove this one, because obviously this would need that. When I come to here, I'm going to do the same thing here. But oh, I checked. Let me just leave it. Let me just leave it. Let me just leave it. But I'm not going to add the persistence. Since it's persistent, it should not be there, honestly. I'm just going to leave it like that for now. And later, we can come back and refactor our code and remove whatever we don't want again. So let's just do that. Let's just do that. So the next thing we want to do now, since we have created a function that actually writes allowance, this one only reads the allowance. This one now writes to storage. So obviously, we need one that would actually be able to spend the allowance. So let's say spend allowance. And inside of it, we will have the env as usual. We will also have the from address. We have the spender, some address, and lastly, the amount the person wants to spend at the moment. Delete everything. We're going to have that. And yeah. So the first thing we want to do is we want to check the allowance. So we want to use this function, read allowance. We want to check how much the person has as allowance there. So we say, what's the allowance the person have? So we call the read allowance function, takes in the env, it takes in the from, this from, let's clone it. That's from. It also takes in the spender. So let's clone this one too. And here we are going to. So we have the allowance. So what's the next thing we need? Okay. The next thing we need now is we want to check the amount this person have. Is it greater than 0? Allowance, is it greater than 0? We could actually, instead of checking if it's greater than 0, let's just check if it is less than the amount the person say he wants to spend. Let's say they allow the person to spend 100 USD. Now the person is saying that he wants to spend 200. So this check is going to check. Oh, this check is going to check if the person have sufficient amount to spend. If not, shout at the person instead of allowance. Should panic. Also, we want to check if the amount is greater than 0. So if the amount is greater than 0, we should do something. We should write allowance. Okay, we have EMV from spender and amount. So this amount should then be, let me just put everything to line up well. I like when the code lines up well. Although I could just do cargo FMT that would format everything now. But let me just do it this way for now. So we have a from our EMV from our spender, then the amount. So this amount, remember the amount, we want to write it that the person have spent the money. So this one will then be allowance dot amount minus the amount the person wants to spend. Then this one would be updated again to allowance dot the expiration ledger. And then we are good to go. So our spend allowance function is literally set up. So at this point, is there any question or can we proceed? Questions?
No question from my end.
Great, great, great. I honestly want everybody to replicate this thing. So have anybody started replicating it?
No.
So because you have not started. What of Levi?
I have not started, sir.
Mubarak Nko?
I need to start, but I'm going to do it.
Okay, great. You see, the good thing about doing this thing is this particular example we are doing gives you every single thing you need to build a Soroban smart contract. First of all, when you want to write a smart contract in Solidity, here are the things you look out for. The storage. How is data stored? That's first thing. Now, when you start thinking of how data is stored, then you now start thinking of the data types that are used in the contract. Now, that's where you are now thinking of how do you use mappings to store? How do you use arrays to store? If you have like a 2D mapping, a 1D mapping, how do you do all of these things? Then the next thing you then do is how do you create a function and use the function to create your business logic to store this data in the storage. The interesting thing about this particular token contract you are creating is that it covers everything. I gave you an example of a 2D and a 1D mapping. What you have here is looking like a 2D mapping. What you have here is actually a 1D mapping. What you have here is just a key to the storage. You get? So with this balance and this state, it's just like an address. Okay, I'm asking, I'm listening.
So I think you're about answering the question I wanted to ask, so, but
Okay, just ask it.
okay, it's about the 2D mapping and the 1D mapping stuff. Like, I can see that the 2D mapping is more of like you calling a struct in the enum, but the 1D mapping, you just wrote the balance and you just put an address there. I don't know
Ex-
if it's any mapping address there.
exactly. It's just that in this one, it's just like you're mapping the address to the storage data.
Which
You
address?
understand? That's just the point.
Which address?
This address now, when can in Solidity, when you're talking about Solidity, uh, and you have this particular balance, let me
Mm.
just quickly go to Open Zeppelin, Open Zeppelin, GitHub. Yeah. So I'll go to the erc20.so GitHub. Oh my God. So here it is. So the ERC20 GitHub, I'm going to go to the ERC20 tokens. Yeah. So now here it is. Look at the balances. Can you see it?
Yeah.
The balances is a mapping of address to what? Uint 256. Look at our own here. The balancing is a mapping of address to I128. You get? And that comes in when we are now using our storage. So
So
it's
it's hold on, please. You said balance so I128. Please, where did you put the I128?
that is the point. Now notice the storage here. Can you
Mm.
see? The
Yeah.
storage is setting. So when we have not done the one for what are they calling it? For balance. You
Okay.
get? We've not done the one for balance. So for the allowance that we are doing, where we have the 2D mapping, you see how we are able to store it, the key and the data. You see the data is allowance, this one. So it can be any data type that is the value. You understand? But the
Mm.
key there is a 2D mapping type of thing, which is the from and the spender, just like this. Look at allowance here. It's a mapping of the from account to the spender. A 2D mapping, like I've always been saying. Can you see? And
Yeah.
that is the same idea that is happening here. And when we start implementing, notice that, let me look for the transfer function where it is actually implemented. Okay, where's the update function itself? Updates. Can you see? Now,
Yeah.
look at balance. This is serving as the key, and this is serving as the value. So this is how you set key to value here in Solidity. You get?
Yeah.
So once you pass in the key here, you should be able to get what is inside this key. The key to balance is here. You should be able to get it, and you get it here and save it in this variable from balance. You understand? Then if you want to store something there, you just say the balances into square bracket from, and then you have your balance. You get? You can
Yeah.
store anything you want to store into the balance there, just like that. So the same thing applies here. So there is this kind of fundamental knowledge you need whenever you are building any smart contract. I mean, any smart contract. At the end of the day, the language might be different, the idea or the implementation might be different, but the fundamental is the same thing. And once you can get that fundamental, there's no way you cannot write or build any smart contract. You'll be surprised if I tell you I write Inc. smart contract. Be surprised if I tell you I write Concordion smart contract, Solana smart contract. It's easy for me to write all of these smart contracts because I'm able to get the fundamental of it. And then having the knowledge, the fundamental knowledge, you can then use that, apply that to how the language used for the smart contract is then used, or how the framework for the smart contract is then used. As long as you have all these fundamentals, you are good to go. So does that make sense?
Yeah, it does. Just that I saw something like
What is it?
there's like an attribute that maybe, for example, okay, actually that was actually just used for just integer kind of enum though. I think it's only available for integer kind of enum. Wherever
What
it's
is
just
that?
like it's like call it like it represents like I think I don't know how to pronounce it though, but it's more of like let me type it something like this. If I'm correct. Presenting you to or any kind of type, something like this. Putting it on top of the enum, something like this. So,
Oh,
yeah.
so where did you see this one?
Oh, it's from the Stellar Docs.
Excellent. So now there are different ways. As you can see, what you just typed here is looking like a procedural macro. So now there are different ways to convert your data type. And that's basically one way to convert your data type. You understand? I've not gone into this particular macro to see how it is being done, but I can literally tell you that is what it does, basically. I think Levi have done something close to this before, right? Levi. Is Levi with us?
Sorry, I didn't hear what you said last. My network is kind of shaky.
Okay, I said I think you've done something close to this. Data type conversions.
Okay, yes, I have.
Exactly. So I was trying to explain to her when she asked about this type of procedural macros, how you do the data type. So I was pointing it to her that, okay, you've done something like this before. So just like I said, once you have the fundamental knowledge on how smart contracts are written, the language is not the problem. The syntax is not the problem. You would write the smart contract. So that's just it. I'm trying to teach the fundamental and not just the contract itself or the language itself. So right now, the next thing we want to do is we've created the admin.rs, we've created the allowance.rs, we've created the storage types.rs. The next thing we want to create now is balances.rs. But before we proceed, hope everybody really understands. Is there anybody that doesn't understand?
I'm catching up gradually. Like,
Is there any part you did not understand that is making you catch up gradually? I'm intentionally typing this thing I'm typing, and I want to use it to ask a question. But I'm listening to you, Mubarak.
yeah, so because there's some part that I missed, right? I'm hoping when we start implementing this balance function, I can be able to catch up from particularly what you just discussed around this allowance balance and then the allowance balance key.
But you got the allowance.
Yeah.
Okay, great. Okay, great. So here's my question to you, Mubarak. I'm trying to type. You see, let me even bring this allowance to this side. Notice that I imported the storage types here, Abby. And I imported
Yes.
the data key here. I'm trying to do
Yes.
the same thing here. Why am I having this error?
Hmm.
Why?
Okay. Where the storage type, we're getting the storage type from allowance, right?
We are getting allowance from storage type. And yes, storage type. Storage type is just a crate. You see, it's a lib.rs crate. You get. But now I'm trying to import it here, but I'm getting error. Can you explain to me why I'm having this error?
Okay. So this is not something that has to do with visibility, right? Because they are public, we should be able to get access to them. Okay. So what could it be?
The question is not just for Mubarak, Levi, Coxie.
Can you take your cursor to that data type? Like, let me see, like, no, inside the allowance.
Inside the allowance. Remember, I'm just importing data type, data key. I'm not importing just allowance. It's the data key I'm importing. But what? Just tell me what you want me to do, and I'll do it.
Can you take your cursor to inside balance where you do the imports?
Inside balance.
Yeah.
Yeah, I did it. I don't understand. Okay, yeah.
Okay. So
It
so
means
I
yeah.
think yeah. So yeah. Can you go to your lib.rs?
Okay.
More very interesting. So it's here, right? We have the storage type here.
Yes.
Um, can you
Can
take
you
your
try
cursor?
importing guys? You try
That
importing the other um data type and see if it will to import first. Let's
Balance.
see generally.
you said I should do what? Can you tell me what to type?
Can you try first of all importing the other data type from that storage types?
Which other data type?
The other one's there too now.
Okay,
Import
okay,
on that one first. Let's see if
okay,
it's going
yeah.
to sure.
So apart from data key, we have allowance data key, Abby. You want me to try importing this one? Then we have allowance value, right? Okay, I've done this, but we are still having error. Why?
Okay, can
Why?
you put your cursor on the error? Let's see what the error is saying.
I don't want to click on the error because obviously that will give you a direct answer to it. I want you guys because
You've not in declared the module in the library file.
thank you very much.
With
I
the,
believe
what
also
is
should be the
declared
one
there?
give the answer to this question actually.
Hold
I
on,
believe that because
hold on.
okay,
We are seeing mode storage type here, right?
yes.
So what other declaration are we going to do here? Because
She just made mention of it. We are meant to add balances here because we just created this.
this is interesting. So
Without adding balances, it's not possible for us to get access to other data here. And notice that the moment I added balances, the color of this thing changed somehow.
yes.
So that is why. Let me remove all these ones that we added. Okay. So we've added balances. So, but we are still having problem. Let me fix it.
Yeah, we will not use. Okay.
So let me just type it out. Let me see. Okay. Use create. storage types and data key. So here it is. I expected Coxie to give the answer to this question because at the beginning of this class, she asked the question before even others joined. This was the question you asked me, Coxie. Have you forgotten?
I was saying storage types there now. You already imported it already.
But I'm using storage type, but storage type is not where I am working. If I did not import this storage type, I won't have access to it here. Can you see? It will show error. But I cannot even have access. I cannot even connect to storage type if I have not connected this particular crate to lib.rs too. So every single crate that is created must always be connected to lib.rs. I made mention that lib.rs is the entry point to quago.toml here. Here it is. The lib is the entry point to cargo.toml for everything that is happening here. And the moment you now start creating more contracts, you then start adding them to these members, just like I've explained to you guys before. Did you get?
Yeah, that makes sense.
You people don't form my hand though. But thank you, Levi, for saying the correct answer. So let's continue. Are there anything we need? Yeah, we might probably need address and ENV now. It's not probably, we will need address and ENV. Sir. So we add address and then ENV. Balances. We want to be able to read the balances. That's one short thing, right? Right?
Yeah.
Obviously, you want to check your balance of your token. Abby? Balance of. So we want to be able to read this balance. So the first thing we want to do is to create the method read balance. And so what then would be inside that read balance method? Obviously, we have our ENV, and then we would also have the address we want to read the balance of. Now, what should it return? It should return a one I128, right? I128, our balance. So the first thing, normal, we pass in our key. Our key is data key, and this here it is. The data key in this case is an address, as you can see from here, from this data key to the balance. It's an address. So we pass in this address here. We pass it here. Address, and it should return something, our data key. So with this data key, we can get access to our balance. So one thing it would obviously return is storage is obviously always return. I've said this 1 million times, but I'll say it again. The storage is always returning an option enum, right? So we want to destructure that by using the iflet. I have made mention that the iflet is the best you can use to destructure an option enum. So we are going to say iflet sum, and what we want to return is our balance, right? Our balance. And so env.storage.persistent.get. We want to get our balance. But right now, before we get it, we want to know the data type of the balance. We want to know the data type of the balance, and that is exactly where our turbo fish comes in. So for our turbo fish, we are going to pass in the data key and the data type we are expecting from it. So we expect the data key and the data type we are expecting from it is an I128. So we are then going to pass in our key, which is a reference to this key here. And then with that, it returns an I128. How does this know that it is an I128? That is because of the turbo fish here. It's saying the key and the data key, the value here is a I128. If you remember when we were dealing with allowance too, I think we did it somewhere where when we had to get the allowance. We did it somewhere, yeah. Here is where we did it. So we passed in the data we are expecting from this key. And we could have passed in the data key here too. Let me just see. Let's pass in. Did we create data key self here? And see we pass in data key. That passed in data key and then the allowance value. But there's no need. Let's just leave that at that. So that's just that. And so inside of it, we want to return the balance. We want to return the balance. But if it's unable to unwrap or destructure that option enum, it should return 0 since nothing is there. And that's just it. With this, we've been able to read the storage for the balance, how much a person has in his account. So the next one we'll be doing now is we want to create a function that allows a person to receive money into his account. The function will definitely be doing some addition of money to the storage. So we create function receive balance. We name it receive balance. I'm just naming it balance so that just like this, you notice there's a pattern, read allowance. It's just the name, write allowance, and you get. So receive balance, and what will it be taking? It's taking EMV, and the data type is obviously EMV, right? Then it will take the address that wants to receive it and the amount it is receiving. In our case, the amount is I128. So we're going to create a balance, and we are going to call this receive balance. We're going to, in fact, clone this address. .clone. And if we clone it, next thing we are going to do then is to write the balance. Hey. We are meant to write the balance here, but we've not created the right balance. So should we just pause it here and create this as a to-do? EMV. This one is EMV for the balance. To read the balance. Okay. I wanted to use .clone here, but I really don't want to use .clone. But let's just see. Let me see the EMV here. Okay, let me add this here. Let me add this here. Let me add reference here. So we won't have problem. So our time is up. Let's continue from here tomorrow. Let's continue from here tomorrow. Does anyone have any question? Does anyone have any question? I'll stop sharing my screen. Okay, thank you, Mubarak. And I'll stop the recording since there's nobody that have any question. So